Mars, the red planet. For millennia, it has captivated human imagination. With its mysterious red hue and endless desert landscapes, it's a world unlike any other in our solar system. Throughout history, we've wondered whether it could harbor life, or if, like Earth, it once had conditions that supported life. But the truth is, until now, we didn't know for sure. In February of 2021, NASA's Perseverance Rover made its dramatic landing in the Jezero crater, marking the beginning of a new era in our quest to uncover the secrets of Mars. And with Perseverance, we've finally begun to answer some of the most profound questions humanity has ever asked. Did life ever exist on Mars? If so, what did it look like? And could Mars, our neighboring planet, once have been a home for life like Earth? The landing of Perseverance was nothing short of spectacular. After a 7-month journey from Earth, spanning over 290 million miles through the vacuum of space, the rover's landing in Jezero crater on Mars marked the culmination of decades of space exploration, innovation, and ambition. But Perseverance wasn't just landing on any part of Mars. It was landing in a location with extraordinary significance. Jezero crater is thought to have once been home to a massive lake, over 3.5 billion years ago. The ancient lake, fed by a river that carved a delta, has left behind evidence of water flowing through this Martian landscape. And it's these features, river deltas and ancient lake beds, that make Jezero crater the perfect place to search for the signs of ancient microbial life. If life ever existed on Mars, this place holds the potential to reveal the deepest clues. As Perseverance descended into the crater, the delicate process of landing in such an unpredictable environment began. The rover's landing system used sophisticated technology, including a sky crane, parachutes, and autonomous hazard detection to ensure a smooth touchdown. The rover's precise placement marked the beginning of a journey that would explore, analyze, and unravel Mars' long-forgotten history. And it's only just begun. Perseverance wasted no time getting to work. The rover's first significant discoveries came in the form of river channels and delta formations, ancient features that are strikingly similar to those found on Earth. Deltas, on our planet, are formed when rivers deposit sediments as they flow into lakes or oceans. And these Martian deltas, formed billions of years ago, were created in much the same way. What Perseverance discovered in Jezero crater was remarkable. The delta deposits are rich with minerals, shaped by water that once flowed across the Martian surface. The discovery of these deltas tells us that Mars had a much warmer, wetter climate in its distant past. In fact, these river channels are some of the clearest evidence we have that water once moved freely across Mars, a key ingredient for life. This ancient river delta, which fed into a large, deep lake, was not just a water source. It was likely a nurturing environment. On Earth, such environments are teeming with life, from microscopic organisms to complex ecosystems. Could ancient microbial life have taken root in these waters? Perseverance's mission is to find out. Perseverance was not only sent to explore, but to unlock the secrets of Mars using the most advanced technology humanity has ever put to use on another planet. Among its cutting-edge tools, the rover carries Sherlock, an instrument that stands for Scanning Habitable Environments with Raman and Luminescence for Organics and Chemicals, and PIXL, which stands for Planetary Instrument for X-ray Lithochemistry. Sherlock, in particular, is designed to detect organic molecules, carbon-based compounds that are the building blocks of life. Organic molecules may not indicate life on their own, but they provide essential clues about Mars' past. It's like finding fossilized footprints in the sand. They may not tell you who made them, but they reveal a story, a history of something that happened long ago. In 2022, Perseverance made a groundbreaking discovery. Using Sherlock and other instruments, it detected organic molecules in rocks within the Jezero crater. These molecules are complex structures that contain carbon, a fundamental building block of life. While the discovery doesn't confirm life, it opens up a whole new set of questions. Could these organic compounds have been produced by ancient Martian microbes? Or were they the result of non-biological chemical processes? Perseverance's findings will help answer that question. One of the most ambitious aspects of Perseverance's mission is its ability to collect samples from the Martian surface. The rover's drill allows it to extract core samples from deep within the Martian rocks, providing material that will eventually be returned to Earth. The process of collecting these samples is meticulous. Each one is carefully sealed inside a tube, ensuring it remains untouched by the harsh Martian environment. These sample tubes will eventually be returned to Earth as part of the Mars Sample Return Mission, which is a collaboration between NASA and the European Space Agency. These samples are crucial to understanding the geological history of Mars and could hold the key to uncovering signs of ancient life. Whether they contain traces of microbial fossils or other chemical markers, these samples will provide Earth's scientists with a direct look at Mars' past, in ways that Perseverance can't achieve alone. Beyond the search for life, Perseverance is also studying Mars geology, its ancient volcanic past, which could offer insights into how the planet evolved. Mars is home to some of the largest volcanoes in the solar system, including Olympus Mons, which is 3 times the height of Mount Everest. The volcanic history of Mars is critical to understanding its atmosphere, climate, and potential habitability. The volcanic rocks in Jezero crater are particularly interesting. They contain clues about Mars' ancient atmosphere, whether it was once thick enough to sustain liquid water, and how it may have changed over time. As Perseverance studies these rocks, it is piecing together a picture of Mars' transformation from a warm, watery world into the cold, dry desert it is today. Understanding Mars' volcanic past could also help future missions better prepare for human exploration. How did Mars lose its atmosphere? What role did volcanic activity play in its climate? These are key questions that Perseverance is helping to answer. And it's not just Perseverance that's breaking new ground on Mars. With the rover came a small, groundbreaking companion, a helicopter named Ingenuity. Ingenuity was originally designed as a technology demonstration to prove that flight was possible in Mars' thin atmosphere. Ingenuity's flights have been nothing short of extraordinary. Despite Mars' thin atmosphere, Ingenuity has completed over 30 successful flights, each providing stunning views of the Martian landscape from above. Its success has opened the door for future missions to use flying robots to explore Mars and other planets. Ingenuity's ability to fly above Mars' surface has allowed scientists to scout regions that Perseverance cannot easily reach. Its flights have provided new perspectives, helping to guide the rover to interesting features and geological formations. What was once the realm of science fiction, flying exploration on another world, is now a reality, with Ingenuity leading the way. As Perseverance continues its mission on Mars, each new discovery brings us closer to answering the most profound question of all. Could Mars have once supported life? With every sample, every image, every piece of data, Perseverance is rewriting the story of the Red Planet. And in the process, it's helping us answer questions not just about Mars, but about ourselves. This is just the beginning. The search for life, for understanding, for the future of human exploration of Mars is only getting started. With every step Perseverance takes, we move closer to unraveling the mysteries of the red planet and discovering our place in the cosmos.